Hello, someone is there.
Non so se sta funzionando perché la telecamera...
Dice che magari va accesa.
Allora, Chiara mi dice che presenta Giuseppe Cappelli al posto suo. Martina non verrà. Però io non so se loro mi sentono da casa.
Chiedo scusa.
Ah, sì.
Io sono Giuseppe Cappelli e sostituisco il professore D'Avuzzo come chairman.
Ah, ok, perfetto. Io sono Sara, la technical assistant della sessione.
Piacere.
Piacere. Il problema è che tu non riesci a vedermi, giusto?
No,
Ah, perché?
però ti sento. Quindi
Eh, non so cosa fare perché quella?
Allora, in teoria la telecamera deve essere questa, siamo d'accordo?
Eh sì, è quella, che dovrebbe essere addirittura 360.
Quindi ci sarà un modo di accenderla, immagino.
Ok.
E cosa è successo?
Però da me non succede niente.
Guarda magari un attimo la telecamera, le opzioni.
È HP, Windows Virtuals.
Questa non è. Capito?
HP sì è PC.
Ora come microfono voglio questo o quello? Nuovo dispositivo di audio.
Microfono.
Ora si sente da qui, l'audio ora viene da qua.
Ok.
Quindi,
Vediamo adesso se magari è cambiato qualcosa. Ok.
sì, ok.
Ci siamo. Ok. Ora dovresti vederci. Forse.
eh,
Sì, io
in,
vedo 3 cose ci sono.
in teoria vedo, penso sia uno schermo con una basilica e con il logo di ICCSA.
In che senso? Cioè non vedi la... Dovrebbero esserci 3 telecamere, una dove ci sono io, una dove c'è la stanza e l'altra dove ci sei tu. Ora,
Mm,
condivido lo schermo. Vediamo un po' se ora cambia. Ora cosa vedi? Lo schermo
sì,
condiviso con tutte.
sì, vedo uno schermo condiviso e dallo schermo condiviso vedo sì, 3 telecamere.
Ok, prova a condividere la presentazione e mi dici se quella almeno la vedi. Che non ho capito per quale motivo sia così qua. Ogni stanza è diversa. Interessante. Cosa vedi?
Vedo
Sì,
la
almeno.
presentazione.
Ok. Non so, dimmi. Ho alzato al massimo dal PC.
Guardo, però anche lui ha un
Perché?
volume su... Sembra di aver visto.
Forse ora. Possiamo iniziare quando volete. Chiudiamo la porta
Sì.
per evitare... Cioè, non so, anche se... Ah, no, hai ragione. Come vuoi, non so.
Non so, venire a frequentare questa sessione.
Ma quindi possiamo parlare italiano?
Io vorrei dirti di sì.
No, cioè non è che ti parli molto.
No, vabbè, penso che il motivo per cui dobbiamo parlare, vabbè, a parte che è internazionale, però essendo registrata poi su YouTube, quindi...
Ok.
Non so, io quando volete posso...
Prego.
Vai.
Però non so se da casa ci sia... Faccio una cosa perché se non me la canto me la ballo da sola. Non c'è nessuno. Ah, sì. Sì, c'è. Io non so che dirvi comunque. Sì, in teoria sì, però il CER è online, non so se ci senta o... perché me lo dava collegato.
Io vi sento.
Ok, quindi possiamo iniziare...
Non vi vedo, però vi sento.
Non ci vedi ma ci senti. La presentazione si vede?
Sì, la presentazione sì.
Ok. Se volete inizio. Okay, so good afternoon everyone. I'm Sara Faedda. I'm a PhD student of the University of Sassari. And today I will present part of a research project that we conducted with the collaboration of the University of Genova, the professors Ilaria Del Ponte and also Valentina Costa, and my professor, which are Professor Tania Congiu, and Chiara Garau from the University of Sassari and Cagliari. Today I will present this work entitled Addressing Mobility as a Service Inclusive Design through the Engagement of Vulnerable Users, Future Perspective for the Italian Mass. What are the content of this presentation? It's mainly divided in three general parts. The introduction, in which we explored the concept of transport poverty, digital accessibility, and how to engage vulnerable people. Also, starting from the Italian experience of Mass for Italy. I don't know if you know about the project, but Mass for Italy is a Italian project funded by the National Plan of Resilience, in which the main goal was to experience 6 different case study in 6 different cities, in which they implemented the concept of mobility as a service. Just briefly, the mobility as a service is a digital platform in which integrates different kind of transport and where all the users can plan and also buy the tickets and see all the itinerary, all the process of the travel. Just from one application, because right now we have different apps for different that give us different options, buy ticket or plan the journey, etc. The second part is dedicated to the method, and so we explore the regulatory framework starting from the European Accessibility Act. in which there are in which they present the element that we must consider when we create a new website or application, and must include all the universal and inclusive principle design approaches. Also, we explore the different strategies in which we can involve the vulnerable users, and at the end, what is the role of public authorities in the implementation of the concept of mobility as a service. At the end, we propose a multi-step approach about the governance framework in which we can where we can put the concept of an inclusive mass. So why does the research matter? We now know that from the literature, we know that mass can be a driver of social inclusion. Why? For the reason that I said before, the shift from the concept of owning a car to a more flexible, a more multimodal solution integrated in just one digital platform. And also the MaaS, the Mobility as a Service system, can mitigate the physical, economical, but also spatial barriers that would lead to the concept of transport poverty. In this research, we define the concept of transport poverty by starting from the structural lack of accessibility. Accessibility, when we talk about accessibility, we mean about the possibility that all users have while accessing all the opportunity in the places where they live, but also we included the territorial area, the marginal area, the rural area, in which we know there's a lack of transport services. So when talking about an inclusive mass, of course, we think about the vulnerable users, so the users that are they can be excluded from such a system. In fact, what we can say now is that the MaaS allows the vulnerable users two main line of action, which is the reduction of physical and cognitive effort, and also the improvement of universal accessibility. So we can say that MaaS has a potential in terms of social inclusion and also universal accessibility for all. So in this direction, there are three main research problems, which are the identification of the accessibility requirement for an inclusive MaaS platform. So we talk about all the requirements that we need to realize a digital platform which is accessible for all. And also, what are the better ways, what are the strategies to involve the most vulnerable users in order to understand what are their needs in order to realize a more inclusive platform. The second main problem was about the potential barriers related mainly in the process of involvement of the vulnerable users in the process of creating an inclusive platform. And at the end, the identification of the potential recommendation in order to guide the policy makers through the realization of accessible MaaS. So before talking about the main outcome of the research, we conducted a brief review of what are the digital accessibility pillars, principle, the engagement, the strategy for the engagement of vulnerable users, at the end, the experience, the case study of the mobility as a service. So the first pillar, I will go very I'll be fast in this part because I think that we all know about the digital accessibility pillars, which are the perceivability, which is the use of different contrast, the importance of different font size that change based on the cognitive problems of the people. The operability, so the opportunity to really physically use the platform or the devices. An example is the use of larger buttons. The importance to understand, people need to understand the platform, the information that they want to acquire by the platform, so it's very important to use a plain language, which means that the information must be clear, very small sentences with all the most important information. And at the end, one of the things that I think is more related to the mass, which is the use of to the mass or the digital platform in general, when we are talking about transport services, is the use of assistive technology. For instance, like the voiceover, or when we ask, I don't know, I think about Siri on the Apple devices, or Gemini, or I don't know, all the other voiceover that we now use daily. These are all part of the bigger group of the assistive technology that can ensure a more smooth experience for people who travel and use the digital platform. So we talk about the digital accessibility. Another problem was about the engagement of vulnerable people, and there are many strategies in the literature that are explored, but I think that the three main concepts are the association, involve the association as facilitator between the researcher or the policymaker and the vulnerable users. The use of online, offline strategies to recruit, to engage vulnerable users, and at the end, a concept that we found very interesting nowadays, I think it's very popular, the concept of community of practice, which are a group of people that comes together to solve a common problem. Just maybe an example of community of practice can be comitati di quartiere. What we learn from the Mass Italy experience. Here we decided to put as a case study the Mass for Italy, because from the 6 cities that implemented the pilot project, but 4 of them also included the vulnerable people in the pilot project. So, talking about the methodological approach, there are 3 critical dimensions, which are the assessment of mobile app features in terms of course, universal accessibility, how to engage the vulnerable users, and what is the role of public authorities. At the beginning, I said that we explored the regulatory framework, starting from the accessibility requirement for mass and what does the normative says about it. So there is the web content accessibility guidelines that gives the main requirement for an accessible platform. And then the European Accessibility Act, which it almost shifts the attention from the concept of accessibility not as an optional feature, but as a functional requirement, like a mandatory requirement. From the point of view of the engagement of vulnerable people, there are, of course, some barriers, some problem in the process of engaging in these target people, which are the structural barriers, like the use of inadequate communications channels, and also the so-called digital divide. The second one is about the psychological barriers, which relates mostly to the skepticism toward the authorities, the public authorities. And the third one is about the methodological barriers, which mean that late planning or this decision-making process are not does not involve properly those kind of people, those kind of vulnerable, the vulnerable people. So related to the barriers to the involvement of such the vulnerable users, we find that, of course, it is important to use a participatory approach that integrates interviews, focus group, workshop, or all these kind of activity that actively involve the vulnerable users. And also the use of the AI. We talk a lot about AI in many fields. And so we found that the integration of with the AI can be an instrument of support in the stages of involvement and also for vulnerable users. At the end, we also explore what kind of role can the public authorities have. And mainly they can define the definition of they can define the public standards in order to establish what are the physical and digital requirements to ensure fair and universal access to new form of urban mobility. Also, the agreement, the more practical, the agreement and the contracts between service provider and public authorities. And of course, the last stage of the process is about the monitoring of the implementation of such a system. So, at the end, we propose a three-step governance model. The first step is about the empowerment of strategic framework. We say that the public authority are the primary coordinator who sets all the requirements and the rules that compliance the accessibility standards. The second aspect is about the co-design process. So how to involve vulnerable users in the process of realizing an inclusive mass system. And in the end, the role, the institutionalization, which means the monitoring of long term of the project, of the implementation of the project, with the collaboration of the association that were involved from the beginning. Association of vulnerable people involved from the beginning. We also put a brief case study, a very small case study, which involved the Italian Multiple Sclerosis Association, ISM, and also the University of Third Age of Alghero, in which we provide them a set of questions. We provide them a questionnaire in which they mainly have to say what are the barriers in the use of digital devices, what are the barriers during the daily travels, and also what do they expect, and if they think that a mass system can be an instrument of support for their travels. In order to do so, we realize different activities, a face-to-face activity, so that we can directly involve them in the activity of the questionnaire. And also other activities are related more of the use of online, like social media and etc. What are the results of this experience? Unfortunately, it's not as I said before, and this is the proof. It's not very easy to involve those kind of users, mainly also because it requires time to properly involve them. So this activity was related to my PhD research. We didn't have really the time to establish a relationship with vulnerable users, even though we had the association as facilitator between us. So this is of course a limit, but the research is still open. So hopefully in the future we will have the chance to expand the sample involved. I said before that, and I'm finishing, I said before that the AI can be an instrument that can help the realization of such a system. And mostly when we talk about the tailor experience, the tailor-made experience for each users. So the AI can, from the analysis of travel data from the smartphone, etc., can provide travel solutions which are tailor-made on the specific need of the user. Can be an instrument for a cognitive relief because it can exclude transport services that are effectively not accessible for them. So can minimize the cognitive effort. And also it can be an instrument useful when talking about the subscription and how to optimize the package of travel, the tickets that are tailor-made on the needs. Another role, of course, of the AI is more technical, related to more the technical part, and so how to mitigate the bias while analyzing travel data. What are the limits and the future step? As I said, there's a lack of data. There are no actual data accessible from the pilot project of the Mass for Italy experience. The case study that we presented is mainly focused in one regional area and is not investigated in depth. And also the study is based on the official literature of the Mass for Italy experience. So the next step are mainly focused on extending the sample in order to include a larger group of persons. And the key findings are about the involvement of the association that represents vulnerable users. They can make they can have the role as a bridge between us researcher and the vulnerable users. The possibility to have a solution tailor-made on the need of vulnerable groups, and also the role of the public authority as coordinator. Thank you.
Thank you, Sara, for this presentation. First of all, I would like to apologize for not introducing myself before this presentation. So, my name is Giuseppe Cappelli, and I'm a research fellow at the University of Cassino in Southern Lazio. And for this session, I'm replacing Professor Mauro D'Apuzzo, that is unable to be the chairman of this session. From home it's a little bit tricky then there, so if you have some suggestion and so on, let me know. I don't know if you have there are some questions for Sarah and for this presentation.
I have, it's more of a comment than a question, because I've been, how to say, one of the testers of the Mass for Italy scheme in two different contexts. Actually, an urban context, which was one of Torino, and then a regional context in Veneto. And I think, okay, I'm not part of the, let's say, vulnerable categories, or not too much, at least when it's not hot like it was in the last days. But I think, like personally, despite being relatively young, I think one of the main issues with those schemes is always that they inevitably, I guess, they rely on existing apps which were pretty much designed to do something else.
Yes, yes, that's the main problem.
So, like in Torino, the main partner, I think, is Monigo, which used to be my teacher for the finance. And then in Veneto, it's the same actually. It's mostly them. And I think the app is like hardly usable. And this is an issue for me. And I can imagine like it would be impossible to propose to be part of trials in the first place, but then also of mass, like a real life, like full-scale mass scheme to someone which is not as dedicated. Like I'm also professionally interested in how and to see how that works and stuff. So maybe AI
can be a
the whole
tool.
thing was designed before AI because it's a recovery fund.
Yeah.
Thing. Maybe AI could also assist the apps in back office, but us as users in making, actually like making our query a little bit easier, because at least personally, I found that the biggest issue is that when you try to say I want to go from A to B, the app, like it was also one of the points, it proposes crazy travel solutions, which don't account, like now I live in Venice, it usually doesn't account for walking, which is the fastest possible way to go around. Venice says it's free, and I don't really need an app, but then maybe I need to take a train afterwards. And so, yeah, it was just a comment on the potentiality of AI.
Yes, thank you for your comment. It also related to the fact that there is a lack of, guideline. How we have the normative, we have the European Accessibility Act, which says, so in order to have a website that is really accessible, you have to do so. Yes, but how can I do so? How can I really make the point that are on the normative applicable in this kind of application? So it's about define, a guideline in order to realize a more accessible app.
Yeah, because mass needs to become smarter than our habits and easier than our habits.
Yeah.
Otherwise, it just go another crazy step like I always do.
Yeah.
And one of the problems that we notice actually is, as you were saying, that they are mainly being involved up in the pilot phase where commercial apps actually. So private-led initiatives that do not target that kind of users, and usually they start from the early adopters group, and they don't take into account minorities that are actually less profitable, obviously. While the things that we were saying in the framework is that a publicly led initiative should take into account this thing, maybe only just through a pop-up initially, where you have an AI tool that is saying, okay, I can profile you, you can give me your preferences, your needs, and then I can suggest you something. Even within the commercial app, and in the long distance, maybe thinking about a public initiative that addresses differently the needs of users.
Yeah.
Just the last comment, if I can. Another important thing, first of all, it was really good, like the framework that you gave. And then the point that made me thinking about it, and since you're experts in this field, I would like to ask, since you pointed out the importance of the municipality assuming the leading role, and I think it's another very important thing. I'm just making this reflection. I don't know the institutional framework of PNRR. I know there was funding, there was maybe also people within the municipality working on it. But what I can see, at least within our case studies with municipalities that we're working with, they're always like trying to, or avoiding collaborating effectively. Like, okay, you do the work and then I take the results and let's see if I will use them or not. Or even worse, maybe faking a participatory approach and just having one meeting or two meetings in the beginning and at the end, just to communicate in the facts what happened. And so it's just a question if you're working on these things, if you have seen within the MAS framework or during the PNRR, if you had some case studies, if you notice this willingness of creating this integration within applications and being really interested in this participatory approach, also including the vulnerable categories, which I think it's really fundamental for that.
Okay, thank you for your comment. I can speak from my experience. I was not involved in the Mass for Italy project like Valentina Costa was, so I can talk about my research, the Mass for Sardinia, because this was the main the main project for my PhD research. I didn't want to. I shifted the attention in order to include the vulnerable users, and the response was that they don't really care about the aspect and the potentiality that such application can have if we start from the needs, the preferences of vulnerable users. Because one thing that I don't know if it's not, I don't know what is the problem, but if we start from their needs that of the person that are more vulnerable, everything can be more accessible for all, not just for them, but for all. As he said before, me too, I have difficulties sometimes using the digital app. So if we start from their needs, but what I saw from my experience is that they don't, because it's not easy, because it's a long process. In my research, the part of the engagement of those two users involve like more than 1 year and a half, because you need to build the trust.
Yeah, sure.
So it's that's it. Thank you.
Thank you, Sara. Maybe we can start with the next contribution. I would like to only clarify that we are too late, so we have to fasten up the presentation to be sharp. So next presentation is assessing accessibility to primary education and healthcare services, a comparison of a European dataset and network-based analysis. The author of this contribution are Valentina Costa from University of Genoa, Federico Campanini, and Silvia Rossetti from the Università degli Studi di Parma.
Okay. Thank you so much.
Yeah.
So, hi everyone, I'm Valentina Costa from the University of Genoa, and I'm here to present this research that we developed together with Federico Campanini and Professor Silvia Rossetti on the assessment of accessibility to
primary services, in details, primary education and healthcare services, implementing a comparison.
Sorry, we can't see from on the screen.
Okay, because I see it as shared, but yes, how is it?
Sì, faccio vedere, adesso loro vedono le note però.
Vabbè,
No,
non
forse
danno-
Yeah, now we can see. Thank you.
Ok, I just need to...
Però tu non vedi.
Così non vedo però.
Però la vedi lì
Ok.
piccolina, devi metterla.
Vabbè, grazie. So the idea was to implement a comparison between the EU datasets that are provided regarding this specific subject and a network-based analysis that we have implemented. Our starting point was to focusing on mid-sized cities and the shrinking issue. So the demographic trap, the so-called demographic trap, that sees mid-sized cities losing inhabitants according to a selective outmigration problem, and try to assess how cities, mid-sized cities, can work on their attractiveness to invert aging trends and the issue connected to the fiscal stress insisting on municipalities and the downsizing of public service supplies in order to make cities more attractive to new families that are coming into the cities, but also to the aging population that lives there from a very long time. So our starting tool was the dataset that was published and released from the Eurostat in 2026. And that was a dataset that dealt with an EU-wide grid, a 1 kilometer grid, that locates healthcare services and primary education and assess accessibility to these kind of services via driving times. So obviously, the purpose of releasing those kind of data is a cohesion policy-making process. But our question was, how can we use those data? I mean, they're publicly available for public administrations and local entities, but can they actually use them? They can be useful to support urban planning, or they need to be re-elaborated and integrated. Since we decided to investigate the attractiveness for families and aging population, our focus was focusing on the elderly and the children and their need to access basic services. And the assumption that we did is that actually they usually move by walking or cycling, so not driving, because obviously they need to be usually accompanied by other people. And the other thing is that in their everyday life, they need some specific kind of service. So primary education is one, and the other is the ordinary healthcare services. So not just the hospital, but also the proximity asset. And our idea was to focus the attention on two mid-sized cities that are Genoa in Italy and Karlsruhe in Germany. The nature of mid-sized cities was the thing that we were focusing on, but we started also analyzing that they are very different cities, both from the territorial and geographical point of view, but also from the point of view of demographic trends. So Genoa is a very strongly shrinking context, while Karlsruhe was a shrinking context like a decade ago, but now we see that the demographic trend is going on the other way. So younger people have reached the city and they're living there. So our question was, what if we look at them in the Eurostat dataset, what we can see about accessibility to primary service? And the fact that we notice is that if we look at both maps from the Eurostat dataset, we see that they do not suffer from any accessibility criticality. I mean, the largest part of the city has access to primary education and healthcare services within a 5-10 minutes radius. So the picture that we have from the Eurostat dataset is actually a very positive one. But this thing looks very strange to us, since they're very different cities. They have different structure, different service patterns. So we tried to go a little deeper, and we found three main criticalities to work on. The first one is that the accessibility metric that was used was just the driving time. So if we think about the 15-minute city, the sustainable transition of cities, this paradigm is quite outdated. So the multimodal perspective is completely neglected. And the second thing is that when we look at the service categorization, both on the healthcare and the primary education side, we see that they were taken into account in a very unlabeled way. I mean, after the primary education label, we see that we have primary childcare, but also higher education institutions. So the data set is quite blurry. The selected process was not that performative. And the second thing is that the healthcare structures and assets that were considered was just the urgency ones, so hospitals, not the ordinary care asset that was not included in the dataset. So the thing is that the dataset is described as a way to assess local accessibility, but if we look at the services that are included, we see that they are very, very blurred in their definition. So we tried with an alternative approach by implementing a network-based analysis, integrating data from OpenStreetMap and from regional geoportals to include also pedestrian infrastructure. So to start to work on the multimodal network. And then we assigned a travel time cost function, and we assigned a standard average walking speed of 4 kilometers per hour. And this was due to the need to compare cities that were very different. As we saw before, actually, we have a very steep morphology on one side with Genoa and a very plain landscape on the other one with Karlsruhe. And the final step was to generate the isochrones in order to evaluate local accessibility to the proximity hubs across the territory. And what we saw, actually, the first result was that Karlsruhe dataset was available only within the Eurostat platform, but data couldn't be downloaded due to the multi-level governance of healthcare structures, so that different providers didn't agree to provide publicly available data. So this was the first result. I mean, that data set is very good looking, but if we look in deep, we see very strong limitation in comparing different contexts. On the other end, focusing on Genoa case study, we saw a very fragmented reality. If we look at healthcare services, we found that several service deserts were present if we look at walking times. So the driving times make the situation look much better than it's in reality. And so for the elderly people, this hubs can be not easily accessible in larger part of the cities. While if we look at education, actually the situation is very good. But in this kind, we have cleaned the data set, and this was just primary education asset. So we didn't include all the higher levels of education that the Eurostat dataset have included, actually. So the thing that we noticed is that we have a very strong gap between what we can derive and obtain with the Euro dataset that supports cohesion policy making, but does not provide cross-country comparison, neither proximity evaluations. While on the other side, we see that if we look at the local asset, we can actually work on shrinking cities and how to evaluate whether a city is age-friendly or family-friendly in the real life dynamics, choosing a proximity approach integrating the accessibility one. So the first result is that accessibility-led mapping was not able to evaluate the actual proximity and the actual accessibility for vulnerable groups. So the thing is that we see that Eurostat dataset can be actually useful, but only at higher levels. So the risk is that local policymakers and local administrations use that kind of information to plan the service within the cities. But that could be not effective in tracing service desert and problem for vulnerable groups. So our research now is targeting two main gaps. The first one, to implement three-dimensional terrain model in order to include also the hilly nature of the territory to assess actual accessibility also in cities that have complex morphologies, as Genoa does. And the other step is to work on the multimodal integration of the functions. So to have an integrated model that consider accessibility with public transport, walking times, and driving time in a very multimodal perspective. So thank you.
Thank you, Valentino. Are there some questions?
Just a quick question. Do you think public transport at least on the coast in general, will change the figure a lot?
Probably in some parts of the city, if we look at the coastline, I think it will. I don't know if that will be also in the inner part of the city, probably not. But we need to say that being the city as following the coastline and then with two valleys, actually one of them as the metro line, so probably it will get better, while the other one probably won't change that much.
Other question? I can see you, so if you give me some feedback.
It's okay. I think it's okay. Thank you so much.
Okay, thank you. Thank you, Valentina. Let's move to the next one. Next presentation is about this other work that it's called Resilient Mobility Under Multiple Shocks. The Scudo Project Experience. The author of this contribution are Francesco Bruzzone, Matilde Gasparetto, and Silvio Nocera from the University of Venezia. Okay, Francesco, the floor is yours.
Yes, we just need 1 minute. We have a technical issue with our TV here. Just a sec.
Of course, there's always technical issue. Questa? Perché non si vede lì?
Ok. Guarda adesso.
Però mi dà... Non capisco per quale
Ok,
motivo.
ok, adesso io la vedo qua.
Sì, adesso si dovrebbe vedere, ma non capisco per quale motivo lui non ci veda da casa. Perché ci hanno detto di usare quella, di non toccare niente e... Vabbè, comunque, quello che è.
Okay, do you see the presentation from home now?
Yeah, we can see the presentation, but maybe it's better that you move closer to the microphone because...
Yes,
Now I
yes.
will, now I will.
Okay, thank you.
Okay, so thanks for the introduction. My name is Francesco Bruzzone. I am a postdoc research associate at the Università UAV di Venezia. Together with my research team, we participate in this EU Horizon project, SCUDO, Safe and Comprehensive Urban Development and Transport Management for Disruption-Resilient Operations. So SCUDO is a research and innovation action which overall aims to strengthen the resilience of the mobility system, both urban and regional, under disruption scenarios. So here I will briefly present the project, and most importantly, I will present the first phases of the project where we conducted a literature review, and we developed indicators to try to respond to the questions that are on the slide right now. So how do we actually assess? First, what do we mean by disruption? Then how do we assess the disruptions and their impacts, particularly on the most vulnerable groups? How do we measure resilience more in general? And also, how do we link the fact that more and more disruptions will happen, and they will likely more and more impact the vulnerable groups disproportionately, while having to deal with very quantitative issues like service continuity, recovery time, and so on. So in the method, we follow these steps. These are, I would say, pretty straightforward. So we started with a literature review of both peer review, so scientific articles, scientific literature, but also a lot of EU reports. So both from other EU-funded projects, but also from Eurostat, the European Commission, and all of the European institutions that work with vulnerability and with mobility. The goal was to find disruption types, to assess the diffusion of impacts in both temporal, spatial, and social terms, and also, and this was very important, and we really needed a project for this, to identify existing response measures. So let's say there is a fire next to a major road. What are right now the response measures by the road management authority? And of course, similar questions for all types of possible disruptions and for all type of transport infrastructure and services also. And this was actually quite surprising, because we found out that at least for the project partners, which I will spend some time on later on, there are really no response measures planned ahead. So it's really rare to have an emergency plan, apparently, even for big operators like the Athens Metro, let's say. Also, we wanted to be able to come up with a suitable KPI framework to capture the performances and the impact of the disruptions, both in like past events, but also ex ante, based on some scenario simulations. So let's say KPIs, the combination of KPIs and scenario analysis was supposed to give some substance to the ability of measuring the impacts. Here we can see an overview, a synthesis of the relevant types of disruptions which emerged from the evidence analysis.
So mostly it's climate and weather related disruptions, including flooding, storms, heat waves, wildfire, and smoke. It's also earthquakes and this kind of disruption. And then we have, and we go a little bit more into the, let's say, difficult part, at least for conventional transport research. We have energy and utility related disruptions. So energy supply disruptions and this kind of things. And also we have digital and technological disruptions like cyber attacks, hackers, or even just disturbances of the network. The other day, I think we all saw the news that the trains in Germany, like in the whole of Germany, were halted for 3 hours because of a failed update of their radio communication network. So this kind of things. And then, of course, there are operational incidents like accidents, but also failures of the infrastructure, which can be related to the climate and weather, or can be just failures of the signaling system and so on, and bottlenecks. So the review allowed us to come up with this 6-dimension KPI framework, which so comprising technical and infrastructure, operation and service performance, user and equity, so the socioeconomic part, environment, sustainability, governance and institutional capacity, and then the cross-cutting dimension. And importantly, we understood that resilience to disruptions should be assessed through 2 dimensions. So to outcomes, so if the service is maintained, how fast the service is back to normal and so on, but also through the capabilities. So the potential for resilience, let's say, the preparedness of an institution, of a society to react, including coordination, but also preparedness, and this can be measured through, for instance, the existence and the updating of emergency plans and stuff. The combination of these dimensions, so also having overlapping measures, avoids decisions that can be beneficial for one of the measures, but also maybe not beneficial for others, and should allow ex-ante comparison of potential new measures while also ensuring equity and suitability for all user groups. And yes, I already, I think, expressed why we wanted to get to scenarios in the end. So this table combines basically the qualitative, so it's starting from the dimensions, we develop both qualitative and quantitative KPIs, trying to see at what happens, so the outcomes, and also to why and how the system can respond, so the capabilities. I don't think it's interesting to waste too much time here, but I think it's really important to stress that for every dimension, even the most social ones like users and equity, we made an effort, or we tried to find both qualitative and quantitative KPIs, and the same the other way around. So for technical dimensions like environment, for instance, or even the technical and infrastructural one, we try to have both quantitative, which are more natural, but also qualitative assessments to make sure to always keep vulnerable people inside. So again, I already anticipated we have 4 clusters of project partners, each with a supporting research institution, a public authority, and an actual transport network. So in Venice, we have ourselves as a university, and then we have the city of Venice and the public transport company, CTV. And now they're very small, but the little icons, they show what kind of disruptions we're looking into, and these include energy-related, climate-related, obviously, these kind of things. Then we have Bavaria, and there it's on a regional scale. So we have the Technical University of Munich, and then the motorway network, the motorway manager. We have the Amsterdam region, which is working on their public transport and water transport network, so that is similar to Venice, but on a much bigger scale. And then we have Athens with their metro operators, the sea, and the technical university. So the idea is to find, so to apply these KPIs and to develop scenarios able to assess with small adaptations all of the use cases, which is quite challenging. So the results from the first tests, so now we're in the phase where we collected all data needed, but we have not yet, or we're now developing the scenarios, and we have not yet validated the scenarios in any way. But already applying the KPIs to the data that we have, it already shows that disruptions generate very unequal outcomes, as it's obvious, also as we all know, I think, because people have a very different level of exposure, but also sensitivity and adaptive capacity to any type of disruption. And this includes access to alternatives, financial constraints, but also information barriers like we were discussing for the mass, these sort of things. The literature, and this was important for us to start working with the next phase, normally identifies as vulnerable groups the following that we have here in the list. So, of course, low income and transport poor households, which have fewer alternatives, basically, and also they can't afford to use some of these alternatives, like possibly they can't afford a taxi if the public transport network is failing. Also have carless households, and this is particularly relevant both where morphologically it's hard to have a car, like in Venice, but also where people are used to rely on a very good transit network, like in the Netherlands, meaning that if the transit network fails, it's a big issue. Then, of course, the people with disabilities or the elderly, which have accessibility barriers, but also informational barriers in actually finding what's going on and which alternatives are there. Women and caregivers, because of the well-known and sad condition where they have to make multiple stops in a single day, and they have to cover more functions compared to us men. Migrants and minorities, which might have language barriers, but also often have job constraints in terms of where to go to work, and also in terms of when to go to work. They have some very hard shifts that have been progressively allocated to ethnic minorities. Remember, the project is mostly developed in Western Europe. Greece is a bit in between, but the rest is in Western Europe, and we're characterized by these very recognizable patterns. Then non-teleworkable workers, which means it's those that cannot work from home, like not even in an emergency, and this is related to both the actual conditions or the actual job, but also to the normative conditions. Like in Italy, we have much stricter teleworking agreements compared to Germany, where pretty much since COVID, everyone can still work from home, for instance, and also, of course, rural residents. This graphs synthesizes the literature, basically. So what kind of disruptions are analyzed, which socioeconomic groups are impacted, and then which country or EU region they're from. Not only EU, actually. There is a lot of literature on North America, particularly Canada, about these topics. So you can see there is a pretty big orange line going in that direction. But yeah, it was an interesting output of our research, also to show that unlike what we even us believed when we actually wrote this project, there is a lot about rural residents, and this is interesting because it's always it's always high up in the agenda normally, like inner areas, rural mobility, and so on. But apparently, at least with relation to disruptions, it's one of the most studied fields. So now coming to conclusions, of course, there is nothing extraordinary. Again, this is just the first preliminary part of our research, but I think that stressing that resilience is a combination of outcomes and capabilities, again, is important. And also, I think it's important to notice that this is one of the first attempts to come up with a comprehensive evaluation framework that can actually support measuring the impact of disruptions without, so making sure, let's say, that disadvantaged and vulnerable individuals or communities are not left behind. And now what we're going to do next is we want to finish developing the scenarios, trying to use the KPIs to see what happens in the future, with what will happen with future disruptions. But then we also want to validate those with mathematical modeling. And not only, so again, we would like to repeat what we've done so far through KPIs with mathematical models, assessing both the existing conditions and a set of possible future solutions or further issues. Thank you.
Thank you, Francesco. Are there any questions?
I don't think so, no.
Okay. Thank you, Francesco. Thank you also for your presentation. Now we move to the last contribution, that is improving communication procedures to foster rail cross-border accessibility as a viable connection between Italy and Slovenia. The authors are Caterina Caramuta, Giuseppe Borusso, Giovanni Longo, Chiara Richetti, Francesca Sinatra.
Yes, I'm here. I'm Caterina Caramuta from the University of Trieste. So I'm sharing my screen so that I can show you my presentation.
Thank you.
Okay. So I'll try to be quite short. So the study that I'm about to present you deals with the opportunity of fostering cross-border accessibility thanks to digitalization in communication procedures, which was investigated through a survey on connections between Italy and Slovenia. So as you know, cross-border transport connectivity is crucial for regional integration, but borders often represent barriers to the integration of transport systems and thus to the accessibility of educational and professional opportunities across borders, implying spatial and socioeconomic inequalities. The research objective was to, consisted in the analysis of public transport accessibility in the Italian region of Friuli Venezia Giulia by investigating, on one hand, users' mobility patterns and road public transport accessibility, and on the other hand, the accessibility of cross-border rail connections between Italy and Slovenia. The analysis was conducted in the context of the T4Rail project, which is an Interreg project with the aim of promoting technological innovation and digitalization to support communication procedures in the railway sector, and thus to improve the connections, rail connections between Italy and Slovenia. So to this end, a tool called the T4Rail tool was developed for the automatic translation of predefined operational messages. The project partners from the Italian and the Slovenian sides encompass not only the infrastructure managers and the railway undertakings of the two countries, but also the University of Ljubljana and the University of Trieste for the evaluation activities. As regard the research area, the Friuli Venezia Giulia is a region in the northeast of Italy, which border with Slovenia and Austria, and more specifically, the provinces of Trieste, Gorizia, and Udine are the ones which are the closest one to the Slovenian border. And the Friuli Venezia Giulia is an important gateway for both the freight and passenger transport, since it is located at the intersection of three TEN-T corridors, which are the Mediterranean, the Baltic Adriatic, and the Western Balkan Eastern Mediterranean ones. The survey, which was performed during the TIFRED project, involved residents of the Friuli Venezia Giulia region between December 2025 and February 2026, using a questionnaire consisting of three main sections. The first one dealt with the socioeconomic characteristics of the respondents and their mobility patterns. The second one with the evaluation of public transport accessibility via road and rail. And the third one with the evaluation of cross-border transport accessibility between Italy and Slovenia. And so the questionnaire was administered both in person and online to a sample of almost 400 people living in the main cities of Friuli Venezia Giulia at the border with Slovenia. And at the moment, the data collected during the survey have been analyzed only using descriptive statistics. So regarding the sample of, the characteristics of the sample, most of the respondents were female, belonging to the age group ranging from 15 to 18 years old, and living in Trieste with a quite high level of education. And concerning the mobility patterns of the majority of the respondents, they stated that they travel outside their municipality of residence on a daily basis. As regards the main results of the survey, the investigation revealed that in the city area, the accessibility to the main activities and services through public transport is good, especially with reference to journeys towards education centers like schools and universities. Commercial and health services are also well connected via public transport, while work and recreational activities turned out to be a bit less accessible. Considering the quality of public transport services, the respondents claimed to be satisfied with it, mainly in terms of distance between stops, as compared with the number of available lines and frequency of services. Besides, with respect to accessibility to cross-border work and study opportunities, the respondents found that the connections between Italy and Slovenia are quite poor, especially in case of rail transport. And lastly, referring to the digital tooling introduced by the T4Rail project, so to improve cross-border communication procedures. The respondents were asked to express their willingness to use rail connections between Italy and Slovenia in case of service improvement, achievable thanks to the T4Rail tool, which in these improvements would be the reduction of travel time or the increase in service frequency. And it turned out that the respondents would be quite willing to use the rail mode in case of those improvements. Although many of the respondents expressed a neutral opinion, which suggests that there could be other barriers hindering the mode shift from road to rail, like, for example, the monetary cost and the perceived comfort. So concluding, at the moment, the survey revealed that at the moment, cross-border accessibility via, especially via rail, between Italy and Slovenia is perceived as poor. But the increase in frequency of services and reducing cross-border travel times could increase the rail demand, and so the willingness of passengers to adopt railway services. But it should be noted also that interventions on the demand side should encompass communication and awareness campaign to improve the visibility of those railway services between Italy and Slovenia. And for sure, technological innovations like the T4Rail tool can enhance the attractiveness of cross-border rail transit. And these innovations can also imply positive impacts at economic, social, and territorial level. As regard the future development of the study, the results that I show you should be integrated with the analysis, with the same analysis on the Slovenian side in order to compare the results. And other than using descriptive analysis, also more, let's say, advanced economic models like regression models should be used to better understanding the relationship among the variables, and of course to support better the definition of policies. Thank you for your attention.
Thank you. Are there some questions?
I don't think so from here.
Okay, thank you.
I think we lost the connection. Sì, forse abbiamo perso la connessione. Sì, non so, forse ha perso la connessione. Però rimane sempre frizzato, quindi secondo me non ha... o si è scollegato. Perché noi non dovremmo avere problemi. Ci sente. Però...
Thank you, bye. Grazie.
Bye.
Bye.
Ciao, arrivederci.
Ciao.
Non so che fare. Vabbè, io rimango qua. Non so, magari rientra giusto 04.
Can you hear me now?
Yes, now yes.
Yeah, okay. Sorry, here there are some bad weather condition here in Italy. So I think that was the last presentation for this session. So
Yes.
I would
Yes.
like to thank you for this opportunity and I don't know, enjoy the rest of this afternoon and enjoy this week in Braga. Thank you all.
Thank you so much. Thank you so much.
Bye-bye.
Have a nice day. Bye.
Bye.
Ciao ciao.
Ciao.
Gesù Cristo. Adesso c'è il coffee break. Oggi è terribile, giornata bellissima. Cosa? Non mi vedo,
Appunto, cioè, nel senso, io mi sono impastata 10 volte. Il caffè non ha fatto un effetto, sono bollita.
No, io sono troppo stanca, sì, purtroppo.
No, anche perché abbiamo perso la peggia. Sì, quindi io ho fatto queste cose, adesso devo andare a
E quindi scusa, come fai? Non c'è possibilità di recuperarlo o ormai sono in Italia, direttamente in Italia?
No, mi sembra di capire che è arrivata a Porto oggi, però vabbè, adesso vorrei in albergo, cerco di chiamare. No, se è arrivata a Porto oggi, devo chiamare io.
Così.
Sì, tanto per quello c'è voluto iniziare.
Ci
Per
credo.
curiosità da dove sei partito, come
Da Venezia via Barcellona, però.
Ah, che vabbè.
Non
Non è
scalo.
barco. No, perché anche
Io ho sempre
sono passata
il
a Barcellona.
Io
Stare in
da
Sardegna.
Madrid. Andiamo.
Come
Con che
va?
compagnia?
Quelli.
Ormai cerco sempre di non imbarcare per quelli che
Ma la mia è la più grande del settimana.
no, chiaro. Sì, infatti credo che lo stiraggio dei prossimi giorni lascerà un po' a desiderare. Avrò questi vestiti stropicciati.
Io alcuni anni non avevo pancia.
La regia, no?
Esatto,
Esatto, è successo qualcosa. Ah, siamo noi, alla fine. Guarda, lo presento subito. Quindi la guarda. Scusate.
Ma è possibile
Che errore ti dà?
Perché lo stiamo facendo dal tablet, non dal PC. Adesso ti faccio vedere, scarico la comunicazione.
Ma perché dici che non si vede? Ecco,
Vedi?
c'è.
Allora,
Si
noi
vede
vediamo
qui?
così, però se io entro... Guarda,
No, perché c'hai il DRAM.
Ah, con la
sì, ma non ci
cellulare.
vedeva neanche il CER.
Era qua dentro?
No, il CER è online, è in Italia. Ci
Con
diceva
la
non vi
connessione al
vedo.
cellulare sì, allora mi connetto col cellulare.
Allora, aspetta, intanto qua ti metto lo schermo
La
stesso.
presentazione si vede tranquillamente, siamo solo noi che non ci
Ti
vediamo.
posso
No,
mettere...
mi frega, non importa.
Tu vuoi lo schermo duplicato o esteso?
Ah, che sia quello il problema.
Anche stesso, tanto mi connetto.
Esteso?
Sì.
Va bene, te lo metto esteso. La presentazione dov'è? È già qua?
No,
Ce l'ho
chiara.
la mia, prima
Ok.
con una pennina.
Aspetta.
È in PDF?
No, adesso lo scarico. Non è mai
Ma io posso prendere una di quelle bottigliette d'acqua.
Sì, certo.
Questa.
Ok, lo scarico.
Ho condiviso questo schermo, ok?
Ok, quindi cosa devo fare io?
Niente, sono due schermi. Questo e quello. Questo è quello condiviso.
Io sto presentando una cosa che in teoria dovrei presentare due, perché la ragazza Serena non riesce a venire qua. Quindi...
Vogliamo provarlo?
Sì, adesso ti mando là.
E a livello di... Sì, cosa devo fare io?
No, magari segni la presentazione, sono sempre io.
Tu tranquilla,
Quindi
cioè,
alla fine
non-
sto facendo...
Ok, metto te però speaker. Che
sì, sì, cioè, sì, metti... No, aspetta, un problema...
Sì, vai.
Aspetta.
No, perché stavo facendo quello del...
Proprio belle queste
Io una, guarda, di quasi. No, grazie. No, sono piena di acqua. No,
La pennina?
no, il convertitore.
Ce l'ho.
So perché non ho più carte.
Guarda, a me c'è tanto questo c'è qua.
Cosa?
Ce l'ho simile.
Che cosa? La presentazione?
No, il coso. Da fare.
Che poi io ho lasciato proprio l'adattatore a casa. Perché il cavo ce l'ho. Quindi se c'è una porta da qualche parte, USB-C, posso tranquillamente...
Sì, ho dimenticato l'adattatore, ora vado alla ricerca di un ferramenta che mi possa prendere l'adattatore. Mi consola.
Sì, mi collego dal computer e funziona, vedrai.
Ma no, perché se hai DRAM non va.
No, dico per valutare, stamattina
Ah,
l'ho
ok,
fatto.
fammi vedere l'errore.
Per quello ti dico, ce l'ho fatto stamattina e non funziona ora.
Può darsi che lo stavamo sistemando.
Eccolo cosa mi dice. Per quello? Perché ci stavate lavorando voi?
Ecco qua.
Allora, andiamo sul link.
Questa è la presentazione.
Attaccala là.
Aspetta. E l'altra?
Ah, prova prestazioni, CG. Ecco, ho trovato
Sì. Saranno parlata qua, l'ho ricaricata.
Grazie.
Quali devi prendere?
Devo cercare.
Guarda.
Sì.
A posto. Il monitor 2, quello sotto. A posto.
Ci siamo?
Si vede? Ok.
Questo se vuoi te lo metti grande.
Ok, vabbè.
E qual è che dovevi aprire che non ti si apriva?
No, questo dovrebbe funzionare.
Prova quello che non ti si apriva.
No, non apriva questo, io non vedevo questo.
Prova adesso a aprirne uno.
Ci sono già tutti connessi? Aspetta che intanto faccio... Sono già connessi tutti quanti? Vediamo, prima faccio due. Ok.
Sì. Salve, da casa ci sentite? Vedete lo schermo?
Sì.
Ok, perfetto.
Ha una casa perché non trovo niente.
Ok, perfetto. Dimmi.
Va bene. Ci vediamo dopo.
Cosa è successo?
È zoomato. One second. Ok. Quindi nel caso se rimane. Sì, ma quando anche compri. Okay, so welcome to everyone. One second, I wanted to see you before. Okay. Welcome to USAM session. I'm sorry for this just a little delay, but we had a technical problem, and I wanted to know if there are all speakers of today about the paper vehicular speed profile on rise pedestrian crossing to inform 30 kilometers per hour zone implementation.
Yeah, I'm here.
There is a speaker with us, okay?
Yeah.
Giuseppe?
Yes.
Okay, because we are the unique mail, so.
Okay.
So, and Sofia Narboianni will present the third one.
Yes.
Okay, and the four determinants of micromobility adoption in university campuses, preliminary finding from a small scale city in Italy. Who is the speaker?
Always me, Giuseppe Cappelli.
Okay, and the last but not the least, Enza.
Yes, I'm here with you.
Okay. Always with me, because before we are in another session, so finally, go back and down. So about the first paper, you can see that the title doesn't correspond with the title of the program, because Serena Pirisino, even if I'm always between the authors, the co-authors, but I really want that this paper will be presented by Serena Pirisino, and she had a problem, and finally she didn't succeed to be with us, and she will speak the 2nd of July in the place of this presentation. So this is the reason why you will see this title that it's completely different from the title of the presentation that you can see in the preliminary program. So I don't know, maybe could be better if you will present first. I want to, come si leva la presentazione? Because I will adapt my presentation depending on the time that you can left, okay? So I will put myself as the last one, and I will introduce Giuseppe Cappelli. Of course, if you agree, if Giuseppe wanted to start.
Yeah, no problem.
Okay.
Yeah.
Giuseppe Cappelli will present us vehicular speed profiles on rises pedestrian crossing to inform 30 kilometers hour zone implementation, and he present a paper co-written with Sofia Narboianni, Mauro D'Apuzzo, and Vittorio Nicolosi. So, Giuseppe, the floor is yours.
Yeah, thank you. I'm sharing this screen. Okay. Can you see the slides?
Yes, you
Okay.
can see.
Thank you for this brief introduction. I'm Giuseppe Cappelli, a research fellow at the University of Cassino in Southern Lazio. The title of this work is Vehicular Speed Profile on Rise Pedestrian Crossing to Inform 30 km/h. One of the sorry, I hear my voice.
No, go ahead. Without any problem, we can see the second slide. Do you have any problem?
Yeah, I hear my voice with some delays.
Chiara, I hear a double voice. Maybe because the microphone of the participants TA has the microphone off. If you try to close the TA microphone, maybe we can hear not the double voice.
Okay. I'm sorry that we have some technical problems. So go ahead.
Okay. So one of the most safest way to create traffic calming measure is to apply 30 in order to reduce the number of crowds and severity. Sorry, but I always a little bit frustrated. Can you hear me?
Yes, we close our microphone. Maybe for you it's better. Try again.
Okay, I'll try. Maybe let's hope that now it works. So I was saying that zone 30 are an effective way to reduce number of crashes and also the severity of crashes. And one way to apply this zone 30 is to create raised pedestrian crossing in order to reduce the speed in some critical zone. The problem is that higher speed are always associated with crashes and also with increased severity. But if we move in the field of zone 30 km/h, the problem is that they are, how to say, always rely on enforcement, and it is difficult to find some 30 km/h zone that are based on physical measure and countermeasure. So the goal of this presentation is to study the speed profile on raised pedestrian crossing in order to design some spacing between raised pedestrian crossing in order to reduce speeds and maintain these speeds at 30 km/h. According to the literature, when we create some raised pedestrian crossing, there is always more or less a reduction of 10% in speeds. Usually, this speeds is analyzed as 85 percentile speed. That means that it is not the mean speed, but is a speed that has a low probability to be higher. It was also showed that when we install and then when we create a raised pedestrian crossing, there is a strong reduction in fatal crashes, for instance, because the speed is lower than other conditions. But there are also some drawbacks that are related to design. Sometimes raised pedestrian crossing are not designed in a proper way, so they could induce some different behaviors and some risky behavior from drivers as well as pedestrians. In this work, we used data collection. In this work, we used we get data by installing some cameras on pedestrian crossing. We focus specifically on one raised pedestrian crossing near to the University of Cassino. Then we install these cameras on the top of the main building. We mark some milestones on the roads, and then we record the movement, the trajectory of a vehicle, and then we extract the spot speeds and the crossing speeds and so on. From this field measure that we have gathered, we collect more or less 20,000 speed measures in different milestones that are equal to more than 2,000 number of vehicles. We use some cameras with 20 frames per second that allow us to have a good accuracy when we collect speed value on this raised pedestrian crossing. Going to the modeling perspective, we modeled the deceleration phase when the vehicle is approaching the raised pedestrian crossing with a linear model. So this speed decreases in a linear way, and so the deceleration is constant in this before the raised pedestrian crossing. After the raised pedestrian crossing, so when the vehicle crossed this raised pedestrian crossing, the vehicle start to accelerate with a linear condition. So it means that this speed follow a parabolic shape. So we use a parabolic model as it has been described in this slide. For both model in the deceleration phase and acceleration phase, we have some good accuracy in terms of Pearson coefficient that confirm that this model could be quite reliable. Going to the case study, we collected data on vehicle speed in this raised pedestrian crossing near to the University of Cassino. The length of this raised pedestrian crossing is 6 meters. That is equal to the width of the road on which it is installed, and has also width of 3.75 meters. 3.75 meters. Another important data that we collected is also the road slope. In fact, this raised pedestrian crossing is installed on a 1% gradient road, so it's not completely flat. We collect data mainly on 5 vehicle categories, and in particular city cars, that are the smaller car, the utilitaria in Italian, the sporting utility vehicles, the SUVs, then the sedans, heavy duty vehicle, and lastly station wagon. Before creating before applying all the models and so on, we assessed for the normality within data. So we compare the we extract these cuckoo plots, quantile plots, in order to assess if the data follow a normal distribution. As it's possible to see in the graph, all the data are more or less follow the red line in this present graph. Going to the speed profile, we use that the model that we saw a few slides before in order to model, in order to draw this speed profile. On the left of this slide, we have the sedan crossing speed. We have the speed profile for sedans. And on the right, we have the sport utility vehicles speeds. As it's possible to see, if we focus on the milestone at 0, that is the center of the rising pedestrian crossing, the sedan cross this speed at 20 km/h, while the SUV crossed this rising pedestrian crossing with an higher speed. So going to making a deep dive of the results, we saw that sport utility vehicles crossed the rising pedestrian crossing with the highest speed compared to the other vehicle type, for instance, the city cars and the heavy vehicle. And we saw also that the negative slope is related to a reduction in crossing speed. That means that that a vehicle that is following a road with a negative slope, when it's approaching to the rising pedestrian crossing, slow in a higher way than compared to the opposite condition. In conclusion, by studying this rising pedestrian crossing, the aim of this study was to give a methodological approach to based on speed profile to design 30 km/h zone. By analyzing the speed profile of all vehicle, we found that an optimal spacing between rising pedestrian crossing to guarantee 30 km/h is 40 to 50 meters, but is only a preliminary result, so it should not be taken as a law. We found also that it is important to analyze speed profile, take into account different vehicle classes, because vehicles do not cross the rising pedestrian crossing with the same speeds. And we have also discovered that road gradient is an important factor when we want to study speed profile in general. So, in conclusion, this work wants only to be a preliminary step towards this, towards the evaluation of the effectiveness of this rising pedestrian crossing to create 30 km/h zone. Thank you. And if there are any questions, I'm here to answer. Thank you.
Thank you so much. There are any questions in the audience, online? So thank you. We can go ahead with the second presentation of this session. And sorry. Okay, and I will give the floor to Sofia, to Sofia Nerbayani, and she will speak about gender differences in injury severity in pedestrian and scooter collision, a simulation study using multi-body tools. So, Sofia, the floor is yours.
Thank you. Do you see my screen?
1 second. Yes, of course, we can see your screen.
Okay, thank you. Good afternoon, everyone. I'm Sofia Nardoianni, and I'm a researcher at the University of Cassino sul Lazio. It is a privilege to present our latest work titled Gender Differences in Injury Severity in Pedestrian and Scooter Collision, a simulation study using multi-body tools. This study was developed in collaboration with Giuseppe Cappelli, Mauro D'Apuzzo, and Vittorio Nicolosi, that I want to thank. Our research sites at the intersection of technological innovation and public health. As our urban landscape undergo a radical transformation towards sustainable mobility, electric scooters have emerged as a primary solution for the last mile problem, perfectly aligned with the United Nations Agenda 2030. And
Sofia, I'm sorry if I'm interrupting you, but we are seeing always the first slide. I don't know if you are speaking on the first slide or now the second. Okay.
Okay. Thank you. The urgency of this research is underscored by sobering national data. In Italy, the ISTAT 2023 report show a dramatic rise in micromobility related accidents, reaching 3,365 accidents, a 50% year-over-year increase. This surge results in over 3,195 injuries and 21 fatalities. Most relevant to our study is the increasing conflict in shared urban space. 182 pedestrians were injured in collision with these vehicles. The scooters possess intrinsic characteristics such as the smaller wheels, an higher center of gravity, and, for example, limited braking stability that make them furthermore, with them often documented below 10%. Pedestrian face and higher risk environment where head injury are the most frequent severe clinical outcome. The core scientific problem we identify is the lack of gender inclusive data in safety engineering. Historically, crash tests and standardized simulation have relied almost exclusively on 50% male dummy. This one-size-fits-all approach effectively ignores half of the population. Biological differences such as segmental mass distribution, stature, and neck muscular endurance drastically influence how a body reacts to an impact. In particular, in micromobility accident, where vehicles are light and impact forces initiate complex rotation trajectories, these anthropometric factors are not secondary details. They are the primary determinants of the false kinematic and the subsequent injury severity. To quantify the injury severity, we used a head injury criterion, HIC. While the full HIC formula involves integrating deceleration over time, we used a validated simplification for this study. The mass spring model, where HSC is equal to K multiplied by speed elevated at 2.5, with K became a constant of 33.93, and V represents the maximum head to ground impact velocity. We then translate these HSC values into a clinical probability using Prasad-Merz curves. Our primary benchmark is the HIC 1000. In biomechanical terms, crossing this threshold represents a transition into the critical injury zone, correlated with an AIS 4+ event, which means a severe life-threatening or fatal head is highly probably. In the data that follow, any variable pushing a pedestrian above HIC 1000 is considered a life-threatening parameter. Our study was conducted within the virtual crash environment using Cadix-Siba rigid body impulse models. To ensure accuracy, our methodology was validated against finite element software like MADIMO, showing a strong correlation in HIC outputs. We perform 120 unique kinematic scenarios, systematically varying in several parameters. Pedestrian gender, first of all, a male with an height of 1.75 meter and with a mass of 75 kilograms, and a female with an height of 1.62 meters and a mass of 62 kilograms. Speed from 6 km per hour, that is a pedestrian limit, to 30 km per hour hardware maximum. Vehicle masses 12 kg, 15 kg, and 20 kg. Present a 5 aluminum frames for this. And impact angle 5 direction, including the frontal, lateral, and the rear impact. Our analysis revealed a distinct two-phase impact mechanism. The first phase is the primary impact. The scooter's rigid frame or underboard strike the pedestrian lower limbs or pelvis. This blunt force rapidly shifts the center of mass, initiating a several rotational and trajectory. The second phase is the impact. This is the C driver. Crucially, the vehicle deposits the lethal injury. The ICCSA values are generated by the head streaking the pavement after an uncontrolled kinematic fall. Actively influence this impact energy as the distance of the fall define the velocity in impact. As previously mentioned, the focus of our research is to investigate whether and how gender difference affects the severity of injuries sustained as a result of impact. For this purpose, the HSC values, respectively for pedestrian and riders, obtained from the combination simulation described above, were correlated. In particular, for the pedestrian, the HSC correlation is shown in this graph. The data show a general positive correlation, although there are substantial differences. There is a significant dispersion around the bisector, indicating that the biomechanical response to impact differs substantially between the two genera. The trends show that under the same accident condition, male pedestrians have higher HSC value than women. This evidence could depend on the height and the center of mass. Even among pedestrians, the man is taller. This condition could, in the event of fall, expose the head to impacts with the ground of a greater kinetic energy. Having ascertained this, we intend to investigate how the initial impact variables, set as simulation condition, can influence the pedestrian injury differentiated by gender. To identify the true driver of injury, we use the Pearson correlation coefficient. About initial speed was the lowering of TBI with a coefficient of 0.61 for males and 0.54 for female. This highlights that the injury severity scale predictably with velocity. About the vehicle mass was found to be statistically irrelevant. The Pearson coefficient were near zero, minus 0.01 for males and 0.06 for females, meaning a 12 kilogram scooter is no more dangerous to pedestrian head than 12 kilograms one, for example. Impact angle showed a moderate 0.29 and 0.26, primarily affecting the a landmark is the vulnerability gap. We observed the significant gender divergence in when the critical safety threshold, as previously shown HIC 1000, is first crossed. Male pedestrians breach the threshold at just 6 km per hour. On the contrary, female pedestrians do not cross this line until 60.9 km per hour. This results in a vulnerability gap of 9 km per hour. However, it is important that at the lowest speed of 6 km per hour, the variation magnitude of the are remarkably similar between the two. Data points and female pedestrian tested with a comparable range showing differences. This confirmed that high energy impact and this speed generate an outcomes far beyond human tolerance, making unprotected pedestrian collision extremely critical. To rigorously validate the injury severity trends observed at higher speed from 20 to 30 km per hour, a peer statistical analysis was conducted. And overall, Wilkinson signed rank test on this speed subset yielded no significant results with a p-value of 0.47, indicated that generalized statistically significant gender difference cannot be confirmed across all high-speed scenarios due to extreme data dispersion. To investigate the root case and the root causes of these variants and the isolated higher HIC peaks observed for female dummies, a targeted sensitivity analysis was performed at the maximum speed of 20 km per hour, disaggregating the paired scenarios by impact direction. This in-depth investigation revealed a critical direction-independent biomechanical behavior that had previously been masked by overall variance. Specifically, in all frontal impact, 0 degree and offset, female dummies systematically recorded an HSC value 15% to 26% higher than their male counterparts. Conversely, in rear 180 degree and lateral 90 degree impacts, male dummy recorded significantly worse outcome, with an HSC value up to 52% higher in offset rear scenarios. These findings highlight that in high-energy collision, generic differences are overshadowed by the specific of the second impact. The precise direction of the initial strike dictates the rotational trajectory of the head. This direction specific vulnerability for and the current future condition. It is therefore emphasized that parameters should be investigated to understand the variability across the different scenarios. We must boundaries of our simulation. We use the rigid body cannot account for the deformation in the next sequence. Furthermore, our subject without a regression. We focused only on files, so this can be applied to children. Finally, our simulation assumed unhelmeted subjects, whereas a protective gear would markedly decrease the HSC values reported. In conclusion, our study provides three prime pillars for safety policy. Speed over mass, velocity is the most effective way to prevent fatal trauma. The directional gender divide, injury risk is not universal. Women face higher risk in frontal collision that must be addressed in 1969. Self-explaining rules, of 60 kilometers per hour are permitted use. We advocate for the self-explaining road paradigm. We need geometric traffic calculus such as the chicane and the road prenumbers, reinforced speed where electronic sensing is absent. Without such designs, exposure remain inadequate. Thank you all for your attention.
Thank you so much, Sofia, for your really interesting presentation. There are any questions in the audience? In the audience, there isn't a question. So thank you again. We can go ahead with the next speaker and then the next presentation. The next speaker will be Giuseppe Cappelli. And Giuseppe Cappelli. And we will speak about determinants of micromobility adoption in university campuses, preliminary finding from a small-scale city in Italy. So, Giuseppe, the floor is yours.
Okay. Can switch the mic.
No, it's terrible. Try to switch off the camera because maybe the connection go better.
No, it's my voice back from the woman which so no, it's continuous delay.
I don't know if you wanted to try to go out and go inside again.
No, always also with Sophie, I hear her voice always.
No, we have also the problem with in listening you because the connection goes up and down.
Okay. I switch off the camera, but yeah. Maybe I.
No, it's better. We can listen you in not in a robotic way or in a.
No, il problema è che sento io la mia voce dietro ogni volta, quindi.
Aspetta, proviamo un attimo a spegnere tutti i microfoni. Aspetta un attimo, vediamo se.
Quello dicevo.
Aspetta, sono tutti spenti, vediamo un attimo. Questo è lo schermo, il secondo è lo schermo. Sono tutti spenti.
Però forse quello da dove stai parlando è acceso, quindi quando riparli...
No, adesso prova a spegnerlo.
Ok, grazie. So, I'm back with another presentation. The title of
Fai da solo, perché sono muta, quindi vai da solo, presentati. Lo senti ancora il rimbombo?
No, quando è spento non sentivo nulla.
Ok, allora spengo. A dopo.
So the title of this work is Determinants of Micromobility Adoption in University Campuses, Preliminary Findings from a Small-Scale City in Italy. Micromobility is one of the emerging new transportation modes, and is also one of the emerging most critical transportation modes because there are not so many studies on on e-scooter, for instance, or on e-bike. So despite this new trend that we are facing in all cities across in Europe, but also in Italy and worldwide, there are some significant safety concerns that should be taken into account. In this study that I'm going to show you, we focused mainly on propensity towards micromobility transport mode. So we want to assess which are the main determinants, the main factors that are related to the propensity toward the usage of such type of transport mode. A big gap that we found in literature is that some studies have been carried out in large cities, but there is a gap, for instance, for small-scale city in Italy, such as Cassino, in which there are no study on this topic in these small cities. To evaluate propensity, we use discrete choice model, and in particular, we use ordered logic models to quantify propensity towards micromobility. We create mainly 3 models. The first model to evaluate the propensity for muscular bike, and so to evaluate the determinants that are related to that propensity. Second model in which we evaluate propensity for e-bikes. And the third one in which we evaluate propensity towards e-scooters. The variables that we take into account are social demographic data, university status, current travel habits. We submitted a survey to University of Cassino students, and so we collected more or less 10,000 10,000 answers from this survey. So there is a big data set behind this study. So the city of Cassino is a small city. There are 35,000 residents, but it is small, but there are 2 mainly campuses in this city. The Volcara campus, which around some there are economics and law, for instance, and the engineering department that is located in the city center. So we collect this data as previously stated from university students in Cassino. We obtain more or less 10,000 answers. And before creating this model, we performed some descriptive statistical analysis. What we found that is the 56% of respondents are female, and 50% of all responders are students over 30 years old. 30 years old. The 42% of these students are also working students, and the 60% of these students live in Cassino. The data that we obtain from this survey is both for Italian students and foreign students. So, I mean, there are some social and some demographic differences between these 2 types of students. So, for instance, we have this particular distribution, for instance, of working students, age of students, and so on. From the survey that we have conducted, the most used transport mode is car, and only 1% of students use micromobility transport mode. We asked also students if they are willing to change, to switch to another transport mode, and the 15% of responders are willing to switch to a bike. The 13% are willing to switch to muscular bike, and more or less another 13% is willing to switch to e-scooters. So not so many students use micromobility transport mode, but a lot of them are willing to change their habits. Then after this preliminary descriptive analysis, we calibrate this ordered logic model to evaluate the determinants that are linked to the propensity toward micromobility transport mode. What we found is that on-site students are more willing to switch to bike, for instance, to reach different campuses. Female students are less likely, less propense, less willing to adopt, for instance, traditional bikes. We found also that engineer students and master program students are more propense to move with micromobility transport modes. And we found, in agreement with all the results, that car drivers are more resistant to switch to another transport mode, especially to micromobility modes. Another particular finding was that micromobility is demographically inclusive. That means that, for instance, students over 45 are more willing to switch to e-bikes, for instance. And there is also a large proportion of students that wants to use, for instance, e-scooter to cover the last mile when they are using public transit, for instance. We found also that in general, electric mobility solutions such as e-bike and e-scooters are more students are more willing to switch toward these transport modes, maybe to reduce physical fatigue and also energy expenditure to push the pedal. Female, for instance, are less willing to use micromobility, and this is mainly due to safety perception. And we have also discovered that there is a positive correlation with public transit and train using. So students that use train or public transit are more willing to switch to e-bike, e-scooters to perform their last mile. In conclusion, after the collection of all this data with a survey submitted to all the students in the city of Cassino, we performed some descriptive statistical analysis, and then with this data, we calibrate the three different ordered logic model to evaluate the propensity towards micromobility. With this data that we obtain, the aim was not to create the most performing models, but was to give some policy recommendation and that could be used, and also could be some preliminary findings also for other small cities. For instance, we found that all age group are more willing to use e-bike, so it could be interesting, for instance, for the municipality of Cassino, improve the e-bike sharing, for instance, as it emerged from this survey and from the model that we have calibrated. If a municipality wants to improve propensity toward this mode and also to promote the modal shift toward these transport modes, maybe could disincentivize, for instance, car driving, so increase parking fee and so on, for instance. To improve also the switch to this to micromobility modes, maybe I don't know, the University of Cassino could create some safe parking or charging station, and the municipality maybe could work on the infrastructure level, so create dedicated bike lane to improve safety condition, and also perceived safety condition. Another policy recommendation could be that Cassino is a small city, so maybe the result that we have obtained maybe could be useful for other small university city in central Italy or in Europe. So these are only preliminary results, so this should be taken with some cautions, but could give us some idea on propensity towards micromobility transport modes. Thank you. If you have some question, I'm here.
Hi Giuseppe, I'm back.
Okay.
Thank you so much, and congratulations, because finally, with many errors, technical errors, many of everything, we are perfectly on time. So thank you so much, because you succeeded to moderate also your fantastic timing, you and Sofia.
Thank you. Thank you.
There are any questions? No, also because we are now in perfect time, so I don't know how many time we have. And I give the floor to Enza, Vincenza Torrisi. Vincenza Torrisi, she will speak about toward the multidimensional assessment of urban bikeability, integrating GIS and the user perception. And she will speak also on the place of Luisa Sturiale and Giuseppina Pappalardo. So Enza, again, the floor is yours.
Yes, thank you very much. Just the time to share the screen. Thank you, Chiara. Thank you all. Okay. Perfect. I think that you can see my screen. I just check. Okay. Can you also see when I change the slide?
Sorry, I was mute. Yeah.
Okay, perfect. So, good afternoon, everyone. I'm here with Professor Luisa Sturiale, which is...
Good afternoon.
Okay, which is also one of the authors of this work. And the title is Towards a Multidimensional Assessment of Urban Bikeability, Integrating GIS and User Perception. And we developed this work also with our colleague Giuseppina Pappalardo. She's also from University of Catania. And with this work, we try to answer to a simple but an important question, which is how can we assess bikeability beyond only the presence of cycling infrastructure? So we propose an integrated framework that combine spatial analysis and users' perceptions to better understand cycling conditions in cities characterized by high motorization rates. So just to introduce the topic, bikeability is often evaluated through the infrastructure, and we usually look at where bicycle lanes are located, or for example, how many kilometers have been built, or how connected the network is. They are some key performance indicators that are used inside mobility plans. But however, these provide only parts of the framework, because a bicycle lane may exist, but people may still decide not to use, especially if they perceive it as unsafe, or for example, if the surrounding environment is unattractive. And so this is our idea that bikeability emerges from the interaction of three dimensions, as we can see in the graph on the right. So the cycling network, of course, but also the environmental context and the user's perceptions. So these three components constitute the backbone of the proposed framework and also guide our representation. So here we have the outline of our presentation. So we applied the framework to Catania, which is a Mediterranean city in the southern Italy. Why we choose this case study? Because we think that is an interesting case study for several aspects, because it combines conditions that are common in many southern European cities, because we have a strong dependence on private motorized transport, and so cycling, we will see that still plays a marginal role, and also the existing cycling network is fragmented. And also, at the same time, we have that the metropolitan city has recently developed a Bici plan proposing a much more extensive cycling network. So there is a planning transition. And therefore, we have a city that is trying to move towards more sustainable mobility, but where the current situation is still characterized by several structural limitations. So we think that this makes Catania as an ideal laboratory for testing our framework. So our objective of our research was not simply to map bicycle lanes, but we wanted to understand whether the current planning cycling system is actually consistent with the conditions that encourage bicycle use. So more specifically, we investigated three main research questions. So the first one is how the cycling network is spatially organized, whether, which is the first one in the blue square. The second one is whether it is embedded in environmentally favorable areas, so the green one. And third, how these special conditions compare with the user's perception regarding both safety and comfort. So the expected outcome is a planning-oriented framework that can easily be transferred also to other high motorization cities. So the methodological framework combines three different sources of information. The first one is the official Bici plan, which provides us both the existing and the planned cycling network. The second is the regional cartography, from which we extracted vegetated areas as a proxy for environmental quality. And the third source consists of survey data collected through a structural questionnaire. I will give you more details about it, which investigates mobility habits, but also perceived barriers and incentives to cycling. Rather than producing a synthetic bikeability index, we integrated these three sources in order to compare planning intentions with the conditions actually experienced by users. So, as regards the questionnaire, it consisted of 24 questions organized into three thematic sections. So, it was administered both online and also distributed through cycling in association, but also by using informal networks. Why? Because we wanted to include both cyclists and non-cyclists. And we can consider that our sample, even though it was small and also exploratory, give us valuable insights into mobility habits and also user perception, which are fundamental for interpreting the spatial results. So let's us start from the first evidence that we obtained from our research. And the first one is related to the environmental dimension. So in this map, we show the spatial distribution of vegetated areas across Catania. And two aspects immediately can be noticed. First, the green areas are not evenly distributed. And second, the dense urban core of the area, where of course cycling demand is potentially higher, is also the part of the city with the lowest environmental quality. We can see the red row which highlight the city center with a limited green coverage. And in contrast, larger and more continuous vegetated areas are mainly located only in the peripheral and peri-urban zone. So this means that the environmental context is not homogeneously distributed, and also this may influence both the comfort and the attractiveness of cycling routes. Secondly, we compared the current cycling network with one of the proposed in the Bici plan. So the existing network is relatively limited and fragmented. We can see the existing network in blue and also in yellow-orange. And we can see that there are several disconnected segments which are concentrated in the central area. And the planned network considerably expands territorial coverage. We can see, for example, the line in purple, and introduces a more coherent metropolitan structure. But however, if we observe in this picture, the continuity within the urban fabric remains a critical issue. So this is important because everyday bicycle trips mostly begin and end inside the city, where local discontinuities may significantly reduce the practical usability of the network. And then we compare this spatial analysis, this GIS analysis, with the survey investigation. So the survey confirms that cycling still plays a very limited role in everyday mobility. More than 71% of respondents use private motorized transport for their main daily trip, and bicycle use remains so very limited and almost comparable to walking, as we can observe in the graph on the left. And furthermore, nearly 43% of respondents declare that they do not use a bicycle at all. So this finding clearly indicates that promoting cycling requires much more than simply extending the infrastructure. Moreover, we also investigated through our survey why people do not cycle. In general, safety clearly emerges as the dominant issue. We identify some barriers like traffic danger, but also the interaction with motorized vehicles and the lack of cycling infrastructures. They can be considered the main perceived barriers. And on the other hand, respondents also identify improvements in road safety and also cycling infrastructures as the most effective incentives. It was really interesting also to observe that economic incentives receive much less attention respect to safety-related intervention. So this suggests that users first ask for better condition before asking for financial support. So this slide summarizes, I think, the main findings of our work, because when we combine spatial evidence and the user perception, we can highlight a clear mismatch. Because on one side, planning documents describe a broader, safer and more connected cycling network, but on the other side, users still experience fragmented routes, limited environmental quality, and also low perceived safety. So therefore, bikeability cannot be evaluated simply by counting bicycle lanes, as I mentioned at the beginning of this presentation, by considering the key performance indicators related to the number of lanes, the number of kilometers, and so on. So it depends on whether infrastructural, environmental quality, and also user experience work together. So this integrated interpretation represents the main contribution of our work. So our findings also suggest 4 practical direction for planners. The first one is improving continuity. That should become a priority. Then the second one is intervention, because they should explicitly address perceived safety. Third, green infrastructure should be integrated into cycling planning, because it contributes not only to environmental quality, of course, but also to the route attractiveness. And finally, planning should continuously incorporate users' perception alongside traditional GIS analysis. So just to conclude and to keep in time, our study proposes a transferable framework for assessing bikeability through the integration of GIS-based spatial evidence and also user perception. The case study of Catania shows that expanding the cycling network is of course necessary, but it is not sufficient. and environmental quality and perceived safety strongly influence how infrastructure is actually experienced by users. And we believe that integrated these dimensions can support more effective planning decision, not only in Catania, but also in many other Mediterranean cities facing similar challenges. So I can conclude by saying that bikeability is not simply about building bicycle lanes, but it's about creating urban conditions in which people actually feel willing to cycling. So thank you very much for your attention.
Do you have any question? No? We can go ahead with my presentation. The last, I hope not the least. Dove la trovo, Sara? Aspetta, che qua. One second. Ah, ok, è qua. Per condividerla?
Sì.
Aspetta. Vai. Ok. È l'applicazione di Damiano. Can you listen to me? Can you see my presentation? Please, just...
Yes, Chiara. Yes,
Chiara. Okay, are you alive? Because
I'm here.
Okay. So I can go ahead. I will do my best to finalize. So the title of the presentation is Behind the Station, Multimodal Interchange Hubs in Coastal City for Urban Integration. So this paper is just a little strange. Why strange? Because what that I, with my co-authors, wanted to present was the preliminary steps that we did before the approval of the Progetto Guida B5 that finally is now in the Urban Master Plan of Cagliari. In fact, my co-authors are myself, Francesca Maltinti and Mauro Coni, two colleagues from the transport sector, Laura Peretti, an architect, and Salvatore Farci is the director of the how I can say, the director of planning of the community of Cagliari. And for me is an honor to be inside with this author because, I repeat, Salvatore Farci is he decide everything about your house, the houses that are in all the municipality of Cagliari. So for me, I repeat, it's an honor. And why I wanted to present this in this conference? Because sometimes people see the results of specific adaptation or specific how I can say, specific interpretation in a particular part of the territory, but finally people can be agreed or not, but finally all the fil rouge and all thinking that was before the final realization many times disappeared. But for instance, for this specific analysis, we work more than 1 year for try to identify the best solution for the portal area that is in Cagliari. So I repeat, this paper is strange because finally explain the step behind the approval of a specific project. So this is the roadmap of the presentation. So the foundation, the methodological framework, I changed, but I don't know why. Okay. Did you see?
No, until now, the title.
Okay, I'm the second. So.
Okay, now yes.
Okay, no, it's okay. Left in this way. You can see the second slide. Okay. Okay. So this is the roadmap of the presentation, the methodological framework, and the European precedents. So what that we did is analyze the similar situation of Cagliari in different parts of Europe, and particularly we analyze the similar problem, but by considering different station, different dimension of the station, for understanding also if the problem could be the same or not, or if there are some common elements in analyzing this type of analysis. So we studied the Cagliari node and finally the conclusion. So this is the roadmap of our presentation. So the core question of this research is this one. You can read: are multimodal interchange apps designed mainly as transport infrastructure or as urban spaces that bridge mobility system and the physical city? So this is really the core research question, and we stay many times to try to understand which was the best modality for try to connect different parts of the city in a specific hub in Cagliari. Also because the team was interdisciplinary. My point of view was completely different from the point of transport colleagues. And both of us was completely different from the point of view of Salvatore Farci, that is the director of the municipality of Cagliari, the sector of buildings, of master plan, the director of he decide everything. So. And finally, studying and also try to speak each other. Finally, we find a solution, and I don't want to spoil it too much, but finally, in the conclusion, we find 3 main points in which there is the point of view of each sector, and this was extremely important because finally we are all happy. So we try we discuss too much, but finally we will find a solution. So what that was missing is try to identify a bridge between the transport-oriented approach with urban-oriented approach. And sometimes what that we find so difficult was to identify a comprehensive spatial framework that can bring together in a unique logic. So there was a moment of this path in which we are not agree absolutely. So we have to start from a common point, the best practices around the Europe. So we start with these practices, and finally we try to understand why they were best practices. So we work by identify 3 basic elements: the spatial hierarchy inside the station, the flow separation, if there are flow separation, and also the urban interaction and active mobility. So 3 different elements that we try to analyze by considering different European case study. So what that we identify was that finally, by considering different station, we identify particularly Paris-Gare de Lyon, Marseille Saint-Charles, Madrid Puerta de Atocha, and Groningen. These 4 different stations that was really different because for the atrium, for the pedestrian level, and cycling and micromobility. So for different elements, but finally what that could be merged by the different analysis was that there is a core, a block 1 that is the atrium, a block 2 that was the satellites, not satellites, the satellites, the connectors. We changed the word, and finally the complex system. But finally, large, medium, or a big station. Finally, these are the key elements that are common in the different station. So this is a nutshell, the comparative matrix. You can find, I forgot, I don't know, but copy and paste, I forgot to insert also Groningen, but this comparative matrix let us understand also the modality in which it was possible to integrate and to intervene in the Cagliari case study. And for the analysis in depth, you can read the paper, and here I put just the key elements. For instance, for the Paris-Lyon, I try to identify the monofunctional levels, the vehicular subordination, and also when there are interrupted pedestrian flow. Also, this was extremely important because you must guarantee also the connection, but they, doing that, finally organize the particular path in which there are the car in a unique floor, the pedestrian in a unique floor, and also it succeed to separate the flow of the different mode of transportation, and also for the pedestrian case study. So the second analysis was the Madrid-Atocha, in which there are like an atrium as a urban park. Was fantastic, this station, and also in this case there are the horizontal displacement and the separated permeability, and also this the possibility to see also this tropical greenhouse inside the station. So this is Cagliari, and what that we will try to identify was the separation between what that was really train and what that could be I can say transformed by urban regeneration or by also as a connector between the different parts of the city. So after many study and discussion, finally we identify 3 elements of intervening, and was characterized mainly for the weak spatial hierarchy. In the Cagliari, there is this as a main problem. The barrier effect. I don't know if you know Cagliari. All of you are but if you go in the area of the port before, there is a distinction between the port and the Via Roma, the area in which you can work in the historical center. So this is a problem, because by doing this big separation, this important separation, finally you divide the city, and this was a problem that all together wanted to try to solve. And the third point was the flow collision. There are a particular part in which are extremely critical. So what that we try to do, and I wanted to go directly through the practical implication that finally was approved, the Progetto Guida, is try to identify these 3 main elements: the coastal catalyst, try to reconnect the fracture that are from the area of the Porto and the historical part that is here, And finally, try to insert also the 15 minutes approach, try to trigger the modality in which it was possible to implement the vitality of Via Roma. Because before this project, Via Roma is a place in which it's possible to park. There are so many cars that was parking there, and it was impossible to think about a vitality in this specific area. So what that finally we succeeded to do, I forgot to insert a final photo of Cagliari, but maybe could be also a good intention, because you can see in Cagliari, you can see the transformation, because now it's completely changed. And for instance, instead of the place in which there are the parking, now there is also they put the play zone for kids, and also there are plants. There are not anymore cars, and there is a real connection between the port and the Castello neighborhood, that the Marina neighborhood, that and there is a more connection between the coastal part and the core of the city. So I finish maybe too quick. Okay. So, but I repeat, I really wanted to present what that was behind what that now there is, because I repeated all of these analysis was a analysis that go ahead for many times, and but finally, starting from the best practices, we succeed to create a place in which there are connections. And in Cagliari, we are so critical, I think, in each region, particularly when the major or there are some important change. And for instance, for us in the Poeto area, when close to the car at the beginning, all people was angry, but after many years are all happy, because finally this part is give us a gift for the people that wanted to go to the sea. And the same for that part. It's probably that if you listen, residents for Cagliari don't like the kids area, or don't like the new restoration of all area, but finally is empty of people. So I don't think that this intervention is so bad. So I close my speech and also the session. So, there are any questions? Are you alive from the web?
We are here.
Okay. You are alive.
Yes. I strongly appreciated all the things about the station, because it's really near to our topic of mobility. So
yeah.
I can hear the double voice. But can you hear me well?
No, also us, the connection doesn't work really well. But Enza, thank you so much for your double presentation now and before. I really wanted to thank also Professor Asturiale that is with us. I'm sorry if I forgot to speak about you before, but there are technical problems, and Enza had already started. And I want also to thank Giuseppe, Sofia, and no, please, Giuseppe, switch off your microphone, because here it's like a robot that came. And we can close this session. Thank you so much, and see you tomorrow. Tomorrow with the other section, and thank you so much again.
Thank you, Chiara. Enjoy the conference in person also for us. Bye, bye all.
Vai Giuseppe, vai Giuseppe.
Bye, bye.
Saluta Mauro. Ha già dato via? Vabbè, niente. Vabbè. Ciao, ciao a tutti, ciao.